are studying for the MCAT exam, you have probably noticed that the gas laws come up again and again in the Chem Phys passages. But here's the thing, the MCAT doesn't just want you to plug numbers into formulas. It wants you to actually understand the relationships and then apply them to real world examples like breathing, blood gases, and lab experiments. So today, we will walk through every gas law that you need to know step by step and then connect them directly to MCAT-style questions. Let's start with Boyle's law. The equation is P1V1 equals P2V2 at constant temperature and constant number of moles. This law tells us that pressure and volume are inversely proportional. If one doubles, the other one halves, and vice versa. For example, think about your lungs. During inhalation, the diaphragm expands the chest cavity, volume increases, pressure decreases, pulling air in. You might see a passage describing a scuba diver changing depth. As pressure increases underwater, the volume of air in the lungs decreases. The test may ask you to compare relative pressures at different depths. Make sure that you always ask yourself, if one variable increases, what does that mean that the other one must do? Next, there's Charles' law. V1 over T1 equals V2 over T2 at constant pressure and number of moles. Volume is directly proportional to temperature. As temperature increases, volume also increases, but only when measured in Kelvin. For example, a balloon left outside on a hot day expands. Same pressure, more kinetic energy, so molecules spread out and the balloon gets bigger. On the MCAT, you might be asked if a sample of gas at 273 Kelvin has a volume of 2 liters, what's its volume at 546 Kelvin at the same pressure? Easy setup, volume doubles. Let's look at Avogadro's law next. V1 over N1 equals V2 over N2. Volume is directly proportional to moles of gas. More molecules take up more space, basically. On the MCAT, if you double the number of moles of oxygen in a container while keeping the pressure and temperature constant, the volume also doubles. This law often shows up in respiration passages, like how oxygen volume in the lungs changes when inhaling additional air. All three laws combine together to give the ideal gas law, PV equals nRT, or PIVNERT. P is pressure, V is volume, R is the ideal gas constant, T is temperature in Kelvin, and N is your number of moles. You don't always need to memorize every unit. What matters most is how pressure, volume, temperature, and moles relate to each other. For example, if you have 1 mole of gas at 1 atmosphere and 273 Kelvin, what's the volume? Here you can plug it in, V equals nRT over P. Once you plug in the numbers, you get about 22.4. That's actually a classic fact. 1 mole of ideal gas at STP is 22.4 liters. That's worth memorizing. We also have Dalton's law and Henry's law. These two gas principles do show up a lot on the MCAT. Basically, it's about partial pressures. The total pressure of a mixture is just the sum of the individual pressures of the components. For example, air is about 21% oxygen, 78% nitrogen, 1% other gases. If atmospheric pressure is 760 millimeters mercury, partial pressure of oxygen is 0.21 times 760, or 160 millimeters mercury. Let's look at Henry's law. The concentration of a gas dissolved in liquid is proportional to its partial pressure above the liquid. The equation C equals Kp. For the MCAT, think about oxygen dissolving in the blood in the lungs. Higher partial pressure equals more oxygen dissolving. This is key in physiology passages about gas exchange. Before we wrap up, let's talk about some common mistakes that students make on the exam. First is forgetting to convert Celsius to Kelvin. For gas laws, you always have to add 273 and make it Kelvin for temperature. Another one is using the wrong value of R for the units in the question. Make sure you pay attention to that. Also, memorizing equations without linking them to real-world contexts. The MCAT will almost always tie gas laws to biology. Another mistake is not recognizing when the ideal gas assumptions break down. High pressure and low temperature. It can cause real deviations to the gas laws. So that's your complete breakdown of the gas laws for the MCAT. If you understand these relationships and how they connect to physiology and to lab scenarios, you'll be ready to tackle these questions with confidence. If this video helped you, make sure you hit that subscribe button. I'll see you in the next one.